Yeah, so last session we did arrays, really, from chapter 3. So if you remember, it was just we've got this test class as normal here. How you structure arrays and size them, and you can split strings to create arrays, and you could put objects in them, more primitives, and we worked a bit with arrays, sizing them, the fact that you can have multi-dimensional arrays as well, and that kind of thing. That's all in that test class that we looked at last time. And I think about arrays to remember is that they sort of important to remember that arrays are objects. Even if you're saying, even if you've got an array of integers, it's still an object underneath it, and they're fairly kind of primitive. If you remember, for example, you have to size them up front. You have to size, when you're creating a new array, you have to size it like that. So it's not really dynamic. You can't just do that, for example, and expect it to sort of expand and grow as you want to. You have to sort of size it first. So it's a sort of primitive and not particularly sophisticated, but it's a very popularly used construct, arrays. And if you do want something a bit more, a little bit more sophisticated than that, the other thing that's on the syllabus for the OCA exam is an array list. But what an array list is, it's just one of many collections classes that you're probably familiar with already. So there are various types of lists. Array list is one, which we'll look at in a minute, and there's linked list, there's maps, hash maps, and trees, and all sorts of things. There's a whole set of classes called collections classes, and for the OCA exam they only actually require you to just know one example of that, and it's array lists. So that's what we'll look at now, but obviously you're familiar with the other ones as well, and I think possibly even more than lists on the work that we do in automated testing. We probably use maps even more, because maps contain collections of things that are keyed on something, whereas a list is just a list of objects, they're not keyed on anything. But so maps contain a key to all the items stored in the collection, and lists don't. But that'll hopefully make sense as we start going through it. So array list is a type of list, and it's the one we need to know for this exam. So again, they've just got 3 different types of constructors to show you how to create a list. So you can just obviously no args constructor there if you want to. You can create it with an initial capacity, like if you think you're going to have 10 items in that list, likely to have 10 items, it'll sort of get that space ready for you. Although again, like one of the sessions we discussed last time, there's not much use for that constructor really, because these are dynamic anyway, so they'll resize themselves appropriately. Or you can, here's another example of a constructor for a list. It's a list that takes another list as a constructor. So list 3 is taking list 2 as a constructor, so it's like its starting point. And what array list really is, it basically holds it's basically an array wrapped in an object to dynamically sort of manipulate that array. So you could do it yourself using an array, like we did in Array Tester here. You could create your own array and do all the stuff that we did in this session. But array list kind of abstracts that a bit. It gives you methods whereby it's doing it for you, as you'll see in a minute. So here's some ways of creating a list. Here's another way, and you'll notice I don't think we've dealt with them much so far. You'll notice these kind of angled or diamond brackets here. These were introduced in Java 5, and so here we're just saying give me an array list. We're not saying what's going to be in that array list, but here we're typing it. We're saying this array list is going to be of type string, and so here's one way of doing it, using those angle brackets here where you're declaring it, and here where you're creating the new object. Later versions of Java, I think possibly in Java 8, the Java team realised, well, actually it's a bit of a waste of time having to put that thing twice, so you can now just initialize it like that, or even I think like that. You just don't need it the second time round because you've already done it the first time round. But you can do it that way. You can do that twice if you want to. But here you're just saying you've got some array lists. We're not saying what's in them, and you could put anything in them. You could put strings in them, animals, referring to our zoo class, you know, any objects you want in there. Here you can only put strings in them because you've typed them as strings beforehand. Like relevance of that should come in later on. So here we've got, yeah. Okay, so what this demonstrates is that an array list is a type of list. So let me just sort of comment that out for a second, as it was before. So what we've done here, we've said array list equals new array list. So that's obvious. We say that's obvious. We've got a type, just as we've always done in our demos. Like we say animal equals new animal. But here we've done something slightly different. We're saying list equals new array list. It's not something to worry about too much now. It just looks a bit strange until we've dealt with it, because basically a list is an interface. So an array list is an implementation of that interface. What all that actually means will be dealt with in chapter 4 and 5. But you can type an array list to whatever interface it implements. If that doesn't make much sense now, it doesn't really matter. Just to let you know that you can construct an array list by declaring it as an array list, obviously, because that's what we always do, or you can declare it because it is of type list. The significance of that will come clear in chapter 4. So, but you can't do it the other way around. So you can't do this, for example. You can't say do it the other way around. You can't say an array list is a new list, because that it's an interface. If we just look at that, it's actually an interface. It's not a concrete class. We'll come back to that in a later chapter. Just to let you know for now that array list, there are various different list implementations. There's array list, linked list, ordered list, various ones. They all implement this list interface. That means that they all have to provide certain methods that you would expect of a list, like adding and removing, that kind of thing, which the interface tells them they must implement. But the list itself is not a concrete class. This is. As I say, we'll come back to that. So here, we haven't, in the most recent sessions we've had, we haven't dealt much with our zoo simulation that we had earlier on, but now we'll come back to it again now. So I'm creating a few animals here. Again, we can see here that I've got tigers here. Actually, that's a bit of a mistake. That should be a lion, really, because I called it a lion. Yeah, that's fine. So let's get 4 animals, and again here, similar to here where we're saying list and array list, we're doing a similar thing here. We're saying animal is a new tiger and an animal is a new lion. That's because that's slightly different from here. In this case, array list implements the list interface. But slightly different reason here. It's because tiger extends animal, so tiger is an animal. So it's a similar principle. We can type tigers as animals because they're in their hierarchy tree. So anyway, we've got 4 animals there. 2 of them are actually tigers and 2 of them are actually lions, but they can all be typed as animals. I could type that as lion, of course, if I wanted to. That's fine. All right, but I can't type it as tiger. That would complain. But I can type it as animal because that's the superclass. So I've got 4 animals there ready, and here is where our list comes in, because I'm going to start adding them. So I'm just saying here, right? Okay, here's a new list of animals. It's a new array list. Again, I don't need that empty diamonds there. They're kind of redundant. So here's a list of animals, and I'm going to start putting those animals in using the add method. So that's the first key method of array list. It's actually add. And so adding the 2 tigers, Timmy and Tammy there, and then here's a second method. It's add, but it's with an extra parameter. So this is, you're just adding. If you just add an object to an array list, it'll just add it to the end of the array list. But here you're saying, actually, I want this specifically at position 1. So if you remember, they're indexed from 0. So you'll have tiger. Before this line executes, you'll have tiger at position 0 and tiger 2 at position 1. So you're saying actually put this line in at position 1. So it'll do the 2 tigers there. It'll kind of push the second one out of the way so the tiger can go in the middle. And we should see that if we print that off. We should see that the lion has been put there in the middle of those two. So what I'm doing here, of course, I'm actually iterating through the list using the for loop that we're familiar with now, the shortcut for loop, and just getting the name and the type of the animals in that list. So just ArrayList tester, that's the one. So just see what that prints out. Yeah, so we've got Timmy and Tammy the tigers and Leonard the lion right in the middle because we specifically said put that in at position 1. So, you know, if we'd have just done add lion, it would have put it at the end. So if we'd have just done that, and do it again, it's probably just going to be there at the end. But you can override that if you want to and say, right, I want it specifically in that position like that. Another obvious one, really, remove. And you can again, remove is a bit like add. So add has these two, actually add has several overloading methods, but the two we really need to know are you can just add the object or you can add the object at a specific position. Remove is the same. So here we're removing tiger. So tiger is that one. So it's Timmy the tiger. So we're saying remove the object called tiger, which we know is Timmy. So if we then print that out again now, so Timmy the tiger should be removed from that list. Yeah, so there's the original list, and then Timmy tiger is removed from that. Then I'm adding Timmy the tiger back in again, just for our for test purposes. So I'll add it in again. Let's print it again. And there it is. It appears at the bottom of the list again because you're adding it without any parameters. So it'll, any index parameters. So it'll appear at the bottom of the list. Finally, the remove method also has. You don't need to give the object. You're just saying remove the object at index 1. So the object at index 1 is Tammy the tiger this time. So if we print that, we should find that Tammy the tiger's gone missing. So 2 different add methods, 2 different remove methods. 2 of them involving the index and 2 of them not, basically. So that's fairly straightforward. So as we said right at the top of the class here, you can type these lists using these angled diamond brackets, or you can just choose to use them untyped. It might seem that why bother using extra syntax where you don't need to? Why not just do it that way? And also you could think, well, it's also more flexible that way because I can put anything I want in that list, whereas here I'm more restricted. But of course you want to be restricted, really. You want, you wouldn't want to accidentally add, I don't know, a plant to an animals list or something. So it kind of protects you from doing that. So yeah, so here we are. So we've got another list here, a new array list, but there's no typing in it whatsoever. And I'm going to add those 2 tigers to it. Add the 2 tigers to it. And because I haven't given it any typing whatsoever, I can actually add a string to it. Why not just add a string to it? Because there's no typing in there whatsoever. So you can do that. But then, and if we ignore those 2 for a second and come back to it, if we then try and print that out, a few things that you will notice here. First of all, what we can't do, so just ignoring those 2 lines for a second, this another animal list here. What we can't do is say, okay, get me the animals out of that list, because we haven't typed it as an animal list. We haven't given it any type whatsoever. So by default, they're just objects in there. So we have to do that. We have to say, okay, for each object in the animal list. Now, if we know they're animals, so if we don't have that one in there, if we know they're animals, we can say, we can explicitly cast that object to an animal again like that. So again, it's kind of stuff we've already covered. And we can say, okay, well, I know that's an animal, so I'm telling you, give me that as an animal. You're overriding the default behavior of the JVM, and the JVM trusts you if you tell it that. So if we print that, this second list now, and there they are in the list there. Other animal list. That should only have 2 in it. Is that because Okay, so why's that got 4 things in it? Animal get type. Anyone spot why that's got 4 in it? Because I'm printing animal.getName, another animal list. So here's another animal list, adding tiger 2. So it should only have 2 things in it, but it's acting like it's got... Oh, I'm sorry. Yes, yeah. I'm sorry. Of course, it's just that those are the leftovers from the previous printout, so it's only those 2 we're actually interested in there. Yeah. What we can do to remove that confusion is we can just add like just an empty print line like that, and that just gives us space between. So there we go. So that's the actual printout from that, which is what you'd expect. So here's the trouble with untyped lists. Let's add that string in there. All right, no compilations errors whatsoever. But can you guess what will happen when we do this? Well, what it'll do the first 2 with no problem. Then it'll get to the other one. It'll say, "Oh, right, give me this object. You're telling me it's an animal. Fine, let's cast it to an animal. Oh, class cast exception. I can't convert a string to an animal. I think. Anyway, let's see. We'll see what happens. But that's the danger of, yeah, class cast exception. A string cannot be cast to an animal. So that's the danger of explicit casting. You know, you have to really know what you're doing. Be careful to do it. But there are times when you should use it, of course. So yeah, adding a few more animals just for testing. So we've got an antelope in there called Dave, and adding the lines in there. Yeah, so this is another thing you can do with ArrayList. You can convert them to an array. So if you remember, that's a syntax for an array there, with just the square brackets. And we're saying animal list, which is a list of animals, to array. So to array, that is a method on the list implementations, and turn animal list into an array, and we know there's 5 things in there, so we can tell it to size that array as 5 for now. So we're making a list and converting it into a array. So if I just print that off for a second, yeah, and I'm just telling it there, we'll print out the size of that array, and it's 5. So we've got those 5 items in an array. We can actually go the other way around as well. So we've started with a list, converted it to an array. Let's convert it back to a list again. It's just to demonstrate the methods that are available to us. So this one, animal list 3, I'm going to take that animal list array, which I've just created from a list, and turn it back into a list again. So this time we're using, if you remember that, a utility class. We use that utility class in the arrays session to sort and search arrays. This is another one of its methods, as list. So it'll take the array that you specify and turn it into a list. So if I just do this, just to prove that it's done that. So it started off as a list, turned into an array, then it turned into another list. And if we list the items from it, animal list 3, there they all are. So we've got all those different animals in there, and it's been converted from a list to an array to a list again. So before, we printed out the length of the array we created. So length, if you remember, is a property of arrays. So lists don't have a property called length, but they do have an equivalent. They have a method called size. The key difference being that is a property, and this is actually a method. So animal list.size, well, there's 5 animals in it, so we'd expect that to return 5. There it is. Now, one thing about arrays, they can be of primitive types, you know, like ints, longs, chars, whatever, but they can also be of object types, like strings, animals, whatever. But lists can only be, they cannot be of primitive types. Lists have to hold objects, they can't hold primitives. So if you try to do this, it doesn't compile. So you're saying, list, give me a list of ints, like that. It doesn't like that, because you can't have lists of, there we go, it even says type argument cannot be a primitive type. So lists can only hold objects. So you could try to get round that by not putting those angle brackets in there, saying, okay, just give me a generic list then, I'll sneak these primitives in that way. So do you think if I so I've got list, just a generic list, and this primitive int 2. So if I try to add to that numbers 2 list this primitive 2, do you think that'll compile? No? It's not an object. But surprisingly it does compile, right? So it kind of seems to contradict what I just said. In fact, to make that even more clear, let's just put it in directly as a number. And you think, oh, but you just told me that lists can't be made to hold primitives in there. And it's actually an illusion, and it introduces another concept which we'll deal with more in later chapters. Because for every primitive type in Java, like long, int, float, double, all the ones we dealt with in chapter 2, char, etc., there is what's known as a wrapper class. And you'll see I'm introducing it here, that this integer, the full word integer with a big I, as opposed to just int, like that, the full word integer, that means that is a wrapper around an integer, right? So you might wonder, well, why do you need wrappers around integers? Aren't you defeating the object of having primitive types? Well, there are occasions where you can't get away with just using a primitive type. You have to have them wrapped in an object. And I think it boils down to, object-oriented principles. Everything has to be treatable as an object. Here is an example where you can't get away with using a type, a primitive type, where you're dealing with lists because they only contain objects. But then this example, it looks like we're not passing an integer with a big I in. It looks like we're passing an integer with a little I and an int there, because that's just a literal int. But what happens behind the scenes with these wrapper classes is that if Java realizes you're trying to do something where you need the wrapper rather than the primitive, it auto converts it for you. So I passed in a primitive 2 there, and Java says, oh, hang on, he's trying to add a primitive, he's trying to add this number 2 to this list. Now that list only takes objects, so what I'll do, I'll wrap it in one of these things behind the scenes. Don't need to bother the developer with it, I'll just do it behind the scenes and put it in there as an integer. So that's called auto boxing. And again, wrapper classes are dealt with later on. This is just kind of introducing it. The principle is you can't explicitly type a list with primitives, but all primitive types have an associated wrapper class. So if we just look at integer, for example, this is the wrapper class around integer, and it extends number, so that's like the most primitive type of wrapper class. And you'll see they've got these methods where they return an actual primitive int. So they're kind of like, they're just wrappers around. So you've got your primitive type, this is just a wrapper around it, or object wrap around it. So that's what that is. And here, just to show again, all right, that collections class there, now that is like a utility class, a bit like arrays is a utility class. Collections is another utility class for classes that are considered as collections, like lists and maps and things. So we've got a list of numbers here, and here we're adding these in. Again, it looks like we're adding primitives, but behind the scenes they'll be converted into these wrappers of these. And then you can just sort them. So we're adding them as 99, 5, and 81. If we actually sort them, let's just get the final printout for that. If we sort them, they're sorted into numerical order: 5, 81, and 99. Okay. So that's basically what you need to know about array lists. It's fairly straightforward. But what we can do now is we can again revisit that zoo class that we haven't really dealt with since chapter 1. And you see I've added a few animals down. This package, the zoo package, got a bit kind of messy with all those in there. So I'll just add a package called animal like that, and just put all the animals actually in it. So that's a few different animals here. An animal itself can go in there, and as we're using an IDE, it's okay. Let's give it right. Okay. As I was let's do refactor. As I'm using an IDE, it does it all for me. So it puts you can see it's put them all in the package. And if I open one of these, you'll see it's changed the package there. Change the package there. It's done it all for me. If you were doing that manually, it would be quite a hassle to do that. So we've got all the different animals there. They all extend this animal here, but they're all there. And if you remember, we had a zoo class. Now I've renamed that zoo class that we used in Chapter 1 as zoo first effort, because we bought a nicely refactored zoo that we shall look at in a bit. But let's look at zoo first effort as it was. So if you remember, we had this zoo and we were just randomly putting like animals in there, like, you know, Giles the giraffe there, Laura the leopard. We were just randomly putting them sort of willy-nilly in that class there. And oh yeah, I see now why that's that when I tried to do that conversion, it complained because it's a certain method is now not visible anymore. But that's all right. We can deal with that error in a minute. Just to show you that this class was quite messy, really. There are animals all over the place. If you wanted to change the, I'll comment that out because it's causing a compiler error. If you wanted to change what's in the zoo, we were forced to do a code change. You know, and there's things all over the place, and you know, because they're not in any kind of list or anything, they're just randomly put out there. We had to do the system outs for each one individually, and then we're adding a few more here. You know, and it's all quite messy, really. It's 121 lines of code. So what we've got this time, so this is a newly refactored zoo here, and what it doesn't have any animals directly listed like this. So what we're doing here, we're decoupling this. So this is obviously a good best practice way. We're decoupling dependencies here because we don't directly name any of our animals. All we know is we have got a list of animals. We've got a list of animals, and we provide we've got two constructors. We can pass that in when we construct it, or we can set it because we've got one of our a setter method that will allow us to pass in animals. So this is a much more streamlined zoo here. And what the other zoo did as well, it did a lot of printing out saying, okay, well, we've got this animal, we've got that animal, blah blah blah. So we provide the similar method here, but it's more dynamic. What it's doing, it's printing those same lines out that this was printing, but it's doing it dynamically. It's doing it. In fact, let's take that out first because we can put that in a minute to show what it does if we don't have it. So what it's doing, it's just going to get all the animals out of that list and do those printouts for those animals. So it's a lot more dynamic and streamlined. So where do we actually get the animals from? Well, this is a pattern that's used a lot in automated testing. We can maintain a list of test data. We can maintain a list of test data in a separate class. So here I've got this. This is a test data manager, and I've got an animal list, and I'm just going to, as a static initializer, so you remember these things will load up as soon as the JVM starts, as soon as the class gets loaded. So by doing it statically like that, it's owned at the class level, and it's done right up front when the class is loaded, so you know that that's in memory ready. And we'll just chuck a load of animals into that list there, and then we can, if somebody calls get animal list on this data manager, it will return all those animals to us. So what we have to now put together is this data manager, which contains a list of animals, and this zoo, which wants a list of animals. So we can use this zoo tester thing. So I'm saying, give me a new zoo and call it John's Zoo. So I'm actually going back to this zoo class again, I'm using this first constructor. So what I'm saying is, give me a zoo called John's Zoo. At the moment, still haven't got any animals in it. I'm still not passing any animals into it. So I'm using that constructor with just the name in it. So that's the first line. And there's a system out to say, right, we're about to test our newly refactored zoo. So any more printouts in there? No. So I'll just print that out. It's called zoo tester. Just start that going. I think it's just literally got the it's just got the one liner because we haven't done anything yet. So what we'll do before adding any animals, let's do that print in inventory method. So that's the method I showed you before that's kind of dynamically looks around the animal list and just prints them all out for us. So zoo tester, So let's just print that out, confirm we haven't got any animals at this stage. Right, so we've got a null, one of the horrible things that we always say, a null pointer exception. We hate those. And this gives us a stack trace, so where it happened. So line 15 of this class, when we tried to do the print inventory and going back in the trace to here, that's because we've got, we tried to do something, we tried to get something, we tried to do a manipulation of something that at the moment is null because we don't have anything in that list. So that's why this was in here. Remember, we use if statements very often as defensive code, like guard conditions. So we're saying if the animals list is not null and has a size greater than 0, then print the inventory. If not, just print out we don't yet have any animals. So it's like guarded, it's a guarded way of doing it, so wrapping it up in an if-else statement. So, welcome to John's Zoo, we don't yet have any animals, please try again soon. So, just guarding against null pointers there. So now let's actually, so now we're going to use the set animals method and pass it in the animal list from the test data manager. So this is how we've decoupled that dependency. So the data manager is purely responsible for giving us test data, list of animals, and we're now passing it into that zoo here. And if you notice, we're just using the class name directly. And that's because that's a static method. It's a static method, so we can just call it directly on the class itself. And everything about this data manager is static because we don't want to bother with creating instances. It's basically just a store of objects, and we want to be able to access it statically. And so it's at runtime. It's sort of when the JVM is starting, these all get built up into this list, and in our zoo tester here, we can call that directly there. Put it into the. If you want to abstract it, you could. If you want to abstract it, you could do this. You could just say the zoo tester. You could. It's sometimes people like to save time by combining 2 lines of code into one. Others don't. Others like to just keep them separate because it's. So we could say test animals. We could keep this as 2 lines separately if we wanted to. It's a personal choice, really. So take that out of there and put it there, and then add that there. So you can test animals. There we go. Two lines or one. It's kind of up to you, really. So here we're using the set animals method. Another thing we could do, right? Revision of constructors. We instead of that, we could have just done that. We could have said, build us a new object actually. Call it John's Zoo, and pass the list in there using the constructor. And so here we've called the new word twice, and pointed this zoo variable to it. So as soon as you do this one, the object that was created here is available for garbage collection because nothing's pointing to it anymore. If you remember, that's just revision of garbage collection. So anyway, right, so we've added some stuff to that zoo, and so now we can print the inventory again. And there we go. So the first time round we didn't have any animals. Second time round we've got all these animals, which is great. And just again to show that we're just using one example of one of the methods we looked at before, the add method. So what we can do, here's a new animal now called Rex the lion. So we can get that animal list from the test data manager, and because we've at that point got a list object, we can use the add method that we dealt with in the ArrayList tester class. So let's add a new line to it. Then we have to reset it again in the animals class. So set the animals to that list again, and then do a print like that again. So after adding, that's fairly obvious. We're just adding another animal to it and refreshing the list in the zoo line. So that stopped at Ramesh Rabbit, and this one's now got Rex the lion in there. So that's lots on array lists really, but also it's more really. It's kind of, we've kind of started to look at better patterns really, rather than just we had all our animals here just randomly chucked into this class, and this is a very hard dependency between the zoo class here, the zoo first effort, and the animal class. So here we've removed that dependency. We're just saying we've got a list of animals, we don't know what they're going to be yet. We've removed any actual dependency from. That's a much cleaner looking class there. One other thing I thought I'd show today, it's not actually on the syllabus as such, but I think it's quite an interesting thing just to look at, is that what we always do is we're always doing these system outs all the time, and as you'll see in these demos, I'll continuously be uncommenting those and commenting them again. And system outs, of course, are not best practice in actual production code. They can be quite handy in these demos, but if you were to it's a classic thing actually in code reviews. That's the first thing somebody will spot. Oh, there's some system outs there. Those will have to come out. Because they're not, I mean, if they were in production code, they'd be of very little use, because for them to be of any use, you'd have to be relying on a support worker to be literally looking at this console 24 hours a day and trying to see these system outs as they're appearing. So that's not logically possible. So of course, what we actually do instead of that is use a logger. So I thought just for the last 20 minutes or so, I'd just implement logger here, just to show you how that works. You may very well already know, but it's just a useful thing we could have a look at. So instead of actual system outs, we prefer to use a logger, and one of the classic ones is log4j, Apache log4j, an open source logger that's been used for quite a long time. So what we can do is, if I grab this, is that the one? Yeah, okay. First thing we need to do, now remember, if you remember right back to chapter 1 when we started this whole course, our project is actually a Maven project. So we can put dependencies in it like this. So we can. The way Maven works is a really nice way that Maven works. It has a website, for example. So if I open this, so what I did just before this session, I think I've got it in bookmarks there. Have I got Maven Central Repository? So before I started this session, I thought, oh yeah, I want to do log4j. So let's get that for the guys. What you can do is you can look for log4j like that, and it's basically, and you can see it's here, and you can go in there, and it'll tell you, okay, for version 1.2.17, that's what you need. That's the dependency you need to put in your POM file, your Maven build file. So I've grabbed that, and I'm going to put it in here. It's just a very, very nice way of what we'd have done before we had Maven is we'd have to manually go and download a log4j.jar from the web, and we'd have to somehow put it in our class path, and we'd have to somehow build it into our release notes that jar needs to be put here when we release it, and all that stuff. But Maven takes all that pain away, because it gives you this file called pom.xml, which is in the root of the project, and if you want some third-party jar or anything in it, all you have to do is include it as a dependency there. And it's IntelliJ has even recognised that I've added a new dependency. It's saying, do you want to import these changes? Yes, I do. So now that's the entire log4j functionality is in there, and of course that it could be anything you want in there. It could be like the technologies such as Spring, something Oracle, databases, anything. You could import those dependencies there. So now we've got log4j kind of in our projects and on our class path. So what I'm going to do now, just to make this a bit quicker, I've kind of done some of the code up front, so that we can. What was it there? That one, isn't it? So that we can just like hurry this along a bit. That's the first one I think we need. So we'll just put a logger in there. Say zoo tester. So before the main method there, I'll actually just say, and it's saying, oh, what's this logger class you're telling me about here? So if I go Alt Enter, it's giving me various different alternatives, but if I hadn't put that entry in the POM file before, that wouldn't have been one of the options. But I do want that one because that's the classic one that most people, most developers use. So I'm just saying, give me a logger. I'm calling it static because I'm going to be using it in a static method. But also, you can call loggers static so that all instances of the same class use the same one, so that everything ends up in the same log file. So, final a static logger, and this is how you get an instance of it. You call that method, Apache. You call the Apache logger, Apache log4j logger, and you get logger, passing in your own class to it. So zootest, I'm passing in my own class to it. That's so that when the logger gets initialized, it's up front, it's got your class there, it knows, it'll include information about your class in the logging entries and everything. So it's just an initialization of a class like that. So we've got our logger there, brilliant. So instead of these things here now, we can actually add log entries. So again, I'll go back to that. So we can, yeah, here they are, logger.info. Okay, grab it there. In fact, I'll grab all those. So we can get rid of those system outs, which always kind of look ugly, really. And so now I'm doing it obviously cut something out there. So now we're doing it the logger way. I'll put them all in, then we can just have a chat about what it actually means after, and then finally after adding yeah. So actually, just grab that message so that there's a slight distinction in the messages there. Right, and we don't need that. Again, we don't need to do things like include carriage returns because it'll do it for us. So all the messing about that we do with system outs, we can come out of this carriage returns like that. We don't need them. So now we've replaced all our system outs with logger calls now. After another animal, I accidentally deleted too many of them there, haven't I? So set animals. Yeah, there's just one there as well. That's it. So that's all works fine, and it's compiled. It's compiled as you see straight up, and it's much better. And you can set the level as well that you want to log at, and you're probably familiar with the different logging thresholds. You can at the lowest level you can have debug, which is used when you're developing. Info is like a piece of information that you might want to appear in the logs, but there isn't anything critical. And then there's obviously more. There's like a warning or severe error, those kind of things, and they keep going up. So we'll just keep it as info for now, just to give that example. So if I run that class now, zootester, we've got various logger entries in there, and okay, that's just something. I just have to change this back. I think I need to reinstall this IntelliJ, because it keeps kind of reverting back to Java 5 for some reason, and a lot of these things didn't exist in Java 5, so that's why it's kind of complaining about it. So I think that should hopefully work now. I try that again now. Turn it on back to Java 8. There we go. So that's zootester, and yeah, okay. Well, what it's done is that, yeah, here's the thing to notice. Well, so what it's doing, we are getting entries there, but for example, we haven't got testing our newly refactored zoo. What we're getting is we're getting just these system outs from here. We're getting, right, welcome to so and so zoo, here is our animals, etc., etc. So we're getting the system outs, but we're not getting those logger entries. And it's telling us, actually, log4j warning, no appenders could be found. Please initialize the system properly. So what it's saying is that this is perfectly valid syntax, like you've put a logger in there, made logger calls, but for loggers to work, they have to know what they're appending to. And again, they use that word append, the same as we use with string builder, like you append something to a file, you append something to a console. So what we need to do we need to give it some appenders. We need to say, okay, logger, you must append to this console here, but also I'd like you to append to a log file as well. So if we just where are we like source main. Yeah, so all our code goes in source main Java. Any utility properties files and things tend to go in source main resources. It's just this project structure that these Java applications support. So if I add a new file in there now and call it log4j.properties and add that in there and add it to Git as well, so we can save it in our project. There it is, an empty property, and we're now configuring log4j with some appenders. So I'll grab them here. We want back in there 2 appenders. So one of them is a console appender, so that's going to come out here. Just some standard things. We're saying, yeah, this is like system out because it's going to come out in the console. We want it to have a pattern, and this conversion pattern is really useful. This is exactly what will appear in your log entry. I've got, just to show you differences, I've got a few others here which we can run and see the difference later. It's what will appear. It's the conversion pattern. Is what will appear in your entry. You've got a timestamp, the message you want to log, all the rest of it. So I've got the console appender here, and here is a file appender. It's a rolling appender, so that means that once the file's got to a certain size, or it's the next day comes, it'll stop that file as it is and start a new one again. So let's just call that. I think if there is already a version of that file, I'll delete it. There's the logs, yeah. Just so that we can just see what it looks like. Yeah, there we go. So I'm saying put that file in this location and call it this. Well, of course you can call it whatever you want. Once it gets to 5 meg, roll it. Create a new one again. And again we got a pattern structure which is exactly the same as that one. So if I save that, now if we run that again, it still complains. It's saying still you've got no appenders, and the reason is you can like specify as many appenders as you want to. You could have 20 in there if you want to. Different, with different. You could have trace files, log files, whatever you want. All sorts of things in there. But you can switch them on and off. You can. The key is you can actually switch them on and off. And what you can do what you have to do to tell them what's switched on and off, you have to have this root logger here. So you say, let's put that in there. Top there. So you're saying, okay, I've got this standard out and this file appender here, and I want them actually to be switched on right now. Use them both straight away. If we run that now, we should hopefully get some logger entries. So here we go. We're now getting log entries here in the console. There we are, log entries. And also, if we go to that file here. We now got logger entries in there as well, so and it's giving us the timestamps and things. So that's how logging works. And you can also set a threshold. So I'm saying here, okay, I'm in development mode at the moment. So even if something's got even something as low as debug, I want you to print it. So if we, for example, went here and turned one of those to debug like that. Yeah, and ran that again, testing our newly refactored zoo, and there it is. It's got it. But you can see now that's an info and that's a debug. And what you can do is you can switch it off here. You can say, actually, I don't want debug things printed out. I'm now in in latest. I'm now in production or whatever. They're just trivial. We just want, so now the debug, anything lower than the debug is not shown. And if you just want to be monitoring purely for errors, so you're not cared about all the info and warnings and stuff, you can set it to error, and then only an error will come out. So you can obviously, once you catch and handle an exception, you can log an error, and that when you do have errors in the logs, there can be certain middleware components like patrols and things that are monitoring the logs for errors, and they'll raise a Jira or a call directly, or an email to a support worker directly as soon as they see it. So that's basically how that works. Just to show again, if I just put a few of the change that log conversion pattern. You just have to look on the site really to see what these things mean, but it's just what's going to appear in the log entry. So if we do this one, it just looks slightly different from the previous one. So just reload that again. So the first entries look like that, and then these ones look like that. It's just really to demonstrate that it's highly configurable, really. So do another one there. And again, that should have given some quite different. Yeah. So again, we've got different ones. It's telling us there we're in the main method. So that one gives you the name of the method as well. Line numbers in the what class. So you can just configure those and tailor them to how you want to, really. So that's it really for this session. It's basically we've done most of chapter 3 now, and what we looked at in the array tester class, which I think has kind of disappeared from my view now, but we kind of got a clue as to what's coming next on that. Sorry, it's ArrayList tester. Because when we talked about this integer class here, this wrapper class, that's excuse me. There's a little bit to cover on this. We already kind of covered it in that we know what they are. There's for every primitive there is an equivalent wrapper class. So for an int there's integer, for a long there's long with a capital L, and they just wrap those primitives. And the reason they exist, these primitives, is that certain functionality, certain methods, is designed to work only with objects, and so this is how you get around it. You use these wrapper classes, and behind the scenes you can kind of treat them interchangeably. So I could have added here. I've added just a primitive int. I've added like 3 like that. What I could have done as well, and it should compile just the same. I could have added a new wrapper class, a new integer like that. That's just as good. Also, this just demonstrates as well. If you, again, we're combining what you could do in 2 lines of code. We're doing it in 1, because you could have done that obviously like that. You could have done like here. Could have said integer 3 equals that, and then put 3 in there. But we often combine that into just one line of code, and of course you can do that multiple times. You can like chain these, and you can sometimes end up having 4 or 5 levels. The difference here, you see what that's done. Let's just to make it different, make it that one for. This is an anonymous object there, because we haven't given it a name. We've just called a new. We've created a new object by calling the new. We passed it straight in there. This one is not anonymous. We've given it the name 3, and something's pointing to it. But it's just a personal choice whether you want to do 2 lines of code or 1 there. And again, it's also demonstrating that integer, the object, could kind of be, if this method expects an object, but if you try to pass a primitive, it'll do everything it can to help you. It'll say, well, you're not really allowed to put primitive in there, but I'm guessing you want me to create an integer class like that. In the earlier versions of Java, that wouldn't have been allowed, but it's kind of this auto conversion helps a lot. So that's like just a clue to what's next, really. A little bit on wrappers, and then there's date, time, and timestamps and things, and that finishes chapter 3 then, and then we're on to things like interfaces and abstract classes and things like that in chapter 4. So thanks very much for coming, guys.